So welcome learner to our today's science lesson. And just to remind you what we did yesterday, we were doing methods of separating mixtures. And yesterday, if you can remember well, we talked about methods such as sieving. We talked about methods such as filtering. We talked about picking. We talked about decantation or decanting. Talk about evaporation, and lastly talked about winnowing. Now, I promised to talk about magnetism today as a way of separating mixtures, but it is not possible for me today to do that. That lesson will come later in the week. So, we were talking about the type of mixture that can be separated using sieving, and then what factors to consider. So for us to pick a method like sieving, and we use it to separate a mixture, here the type of mixture should be a solid mixture, and the factors to consider is the size of the particles. The size of the particles, where the bigger particles remain on the sieve and the smaller ones pass through the sieve and are collected on the lower side of the sieve. In filtering, we say that this type of mixture to be separated using this is a type of a liquid and a solid mixture. So solid liquid mixture whereby the solid is insoluble in the liquid. Like for example, sand and water. You can be able to filter. You remain with the materials, the solid materials on the filter paper or even on the cloth that you're using, and then the water will be collected in the container. The water becomes the filtrate, while the solid materials, they are referred to as residue. Then we went to picking, and picking we said, here we are considering a mixture that is solid. But again, we're looking at the fact that the mixture is a solid, and therefore we consider the factors that the sizes of the color of the materials, like red and maybe white, and then also the size of the materials in the case of maize and maybe wheat. Then we came to decanting. We said decanting can be used to separate a mixture of a liquid mixture and also a solid liquid, where the solid is insoluble in the liquid, and so say for example we have water and sand, or water and maize, where the maize will be left on one side, then you decant the water to the other side. In case of liquid, we talked about, for example, those immiscible liquids like kerosene floating on water. So you filter carefully the water, the kerosene on one side, then the water remains on the other container. Then evaporation, we said here it is a soluble solid in a liquid. Like for example, a solid like salt is soluble in water. So if it mixes accidentally, it is going to dissolve in the water. So for you to recover that salt, you need to take the salt solution, which is a liquid, and then you heat it at a very high temperatures. The water will evaporate. You remain with the salt granules at the base of the sufuria. And so we say this one is not encouraged. This method is discouraged because only one substance is recovered, the salt particle, but the water goes away. Then the last one is the winnowing. We say the winnowing, here we're talking about a solid mixture, whereby we consider the weight. The lighter materials will be blown away, and then you remain with the heavy materials on one side. So that is what we did yesterday, and today we want to conclude this particular chapter by just looking at how can we make a homemade filter. An homemade filter is something that you can use, maybe a broken type of a glass, or even you can have a container. The big containers that are 10 liters, you can make one by having this part, the bottom part chopped, then you invert it, use it downwards. So we want to see the materials that are supposed to be arranged in a homemade filter. So its importance actually is to clean, to help clean water, not to make water safe but clean. If for example you have some muddy water, we know that this water which is muddy is mixed with soil particles, so it's colored. You find it brown. So you can put this muddy water in this filter and come up with some clean water on the other side. So this will be the clean water on this side, and for this case this becomes our filtrate. And so this is a jar. So the first material, how we arrange the materials in a homemade filter, we have the first material here becomes the cotton wool. What is the importance of this cotton wool, Lana? This is a question in KCP. The importance of this cotton wool is to prevent all these other materials from coming down into the jar. So prevents materials in the filter from coming into the jar. If we don't have this cotton wool, it means that all these materials, because they are arranged in these layers, they come down into the jar here. So that is the importance of it. So after having this cotton wool, the second part is called pebbles. All of us know what pebbles are from our lessons from social studies. I know there's a place we learn about some stones and all that. So you get as pebbles, you place them there. Then the next material after pebbles is of course charcoal. We have charcoal there. I'll tell you why we put charcoal. The importance of this charcoal is to ensure that it attracts the dirt, and so just to remove the color, so that the water will remain colorless and clear. So this charcoal removes the color. So after the charcoal, we have fine sand. Fine sand is put there. After fine sand, before then we have after pebbles we have coarse sand. I'm sorry about that. Coarse sand. So cotton wool, pebbles, coarse sand, fine sand. Then after fine sand, coarse sand. Before fine sand is where we have the charcoal. Charcoal is there. Then we have fine sand. Then lastly we have the muddy water. You can be able to see how the materials are arranged. So you can just say kope kochafimu. You say kope kochafimu. If you say kope kochafimu, you have gotten how these materials are arranged from down here, from down upwards. Kope kochafimu. So you'll be able to come up with these acronyms and then get yourself the materials, how they are arranged. Now say the importance of this charcoal is to remove the color. Remove the color. You know the water is brown in color, so this charcoal traps the sun particles, and so the color of the water changes to be clear. So on this side we get some clear water. Now there are things you need to note, Lana, that inside this water, we know it's this water that is dirty. We've collected it from anywhere and places here to just make clean, maybe for washing purposes. But if you want to drink it, let us remember that this water is dirty, meaning that it has some tiny germs that you cannot be able to filter here. So what after we have filtered, we cannot take it for home use like drinking, because there are tiny disease-causing germs which we cannot be able to see with our own eyes and cannot be filtered at the same time. So for us to make this water safe for drinking, we boil or add chemicals. So boiling or adding chemicals make this water safe. That is a question in the exam. That how do we make this water safe for drinking? We only make water safe for drinking by either boiling or adding chemicals. When we say adding chemicals, we talk about chlorination. Chlorine. The water gun that you have at home is a chemical. When you add in the water, it kills germs in the water. So filtering is not the surest way of getting clean, safe water. This water is clean, but it's not safe. There's a difference between being clean and being safe. Clean is just the way you look at it, very clean. But inside, it may contain some small disease-causing organisms, microorganisms, that when you take them inside your body, they are going to multiply and cause you a disease. So the safest way of ensuring this water is safe for drinking is by boiling or adding chemicals. Let's get that very clear, learner. So we said the charcoal is another question from this diagram. What is the importance of the charcoal is to remove the color. Once you remove the color, the water becomes very clear. So that is all about homemade filter. That's what I wanted to discuss with you today. But before we finish up, we have 4 questions. Okay, 3 questions that we need to answer regarding what we did yesterday. Number 1 question says, Peter accidentally mixed salt, sand, and iron filings. Accidentally mixed salt, sand, and iron filings. Let's see whether we can be able to answer that question number 1. That is mixing salt, sand, and iron filings. Now I want to explain what iron filings. Iron filings are those small particles that are gotten when you cut a metal, an iron metal. When you cut an iron metal using those blades, you remain with small particles. If you go to the fundis who make doors, you'll see those iron filings. So salt was mixed with sand and iron filings. And the question goes, which of the following are the right steps to follow to separate the mixture? Which is the right steps to follow to separate this mixture? Let's see what you're supposed to do to be able to get this question correct. The mixture is of sand plus salt plus iron filings. Let's see what is the first one to do. The first one to do, of course, will be removing these iron filings. How can we remove iron filings? By passing through the mixture a magnet, because iron filings are magnetic. So we are going to, first step is use of magnet. And use of magnet, you are going to remove the iron filings. The next step, we use arrows to show the next step. The next step will be, now you've remained with sand and salt. But these are particles. You cannot pick them. They are almost of the same size. So what is the next step that you can be able to do? Next step is to dissolve these because salt is soluble in water. You add water to this mixture of sand and salt. So the next one is dissolve. Dissolve the salt. That is adding water. After adding water, you get a salt solution. After getting a salt solution, the salt solution is also having what? The sand inside. So what method can we use to separate the sand and the salt solution? Remember, the salt solution is liquid. What can we be able to do that? Now, here there are 2 ways you can do. You can either, but the surest way is filtering. Because if you do decanting, you can have some traces of sand on the other side. So here we're going to use filtering. So we are going to filter When you filter this, you are going to remain with sand on one side as a residue on the seal. Then on the other side, you are going to have a salt solution. The salt solution you are going to get there, remember we want the salt, you are going to evaporate. So you are going to do evaporation of that salt solution. The water will evaporate and you remain with your salt back. So those are the steps that you should follow to get your salt back. So that is one question. The second question I want to pose to you is that which is the second step in separating a mixture of salt solution and sand? Salt solution and sand. Salt solution and sand. Now I want us to agree that salt solution, looking at these steps, our salt solution now is on this side. So we have arrived at that point. So salt solution already is water that is mixed with sand. So water that is mixed with sand, where do you start from? So you start by filtering. Because it's already sand that is in water. So after filtering, you get to a salt solution on one side and sand on the other side. So after that, you do evaporation. So the second solution after of separating these, of course, will be evaporation. The first one will be filtering, then you go to evaporation. Then the last question, number 3. Which are the steps to be followed for one to recover salt from a mixture of salt, water, and maize flour? The mixture is salt, water, and maize flour. Flour. So it means if it's salt and water, this is already dissolved. So what do we have? We have a salt solution which is also containing some maize flour, and you know maize flour is not soluble in water. We saw it here the other day that when we put maize flour in a glass of water and we stirred so well, we did not get a solution. We got water plus maize flour. So this salty water, and inside that salty water we have maize flour. So the first step will be filtering. After filtering, you will get maize flour on one side, then on the other side you will have a salt solution. That salt solution, for you to get the salt in it, you are going to evaporate that mixture. Evaporation. So that is it. From filtering, and the next one will be evaporation. So that's how we can be able to answer questions in the exam regarding this particular topic. So now I want to give you a few questions before we wind up. But in our next lesson, we will tackle making work easier. Will be our new chapter, making work easier. So prepare well. You realize that you have some devices at home, but you don't know how they make work easier. I'm going to show you in our next lesson. So I'm going to give you some work, and the work is got from page primary science, book 7, page 150 to all through to page 160. Revision exercise 2. Revision exercise 2. Kindly do that work, write the questions, and then give out the answers. So until next time, learner, we are through with our today's lesson. May God bless you. Stay at home, stay safe, sanitize. God bless you.